So now we're going to talk about the fundamental counting principle and permutations. And when we're talking about the fundamental counting principle and permutations, we're talking about possible outcomes. Or sometimes you can read in the question, it will say, how many ways can something occur? There's always at least one of these, sometimes two or three on the ACT. So let's think about this. It says, Jose is trying to pick out an outfit for the first day of school. He can choose from 2 pairs of pants, 6 t-shirts, and 3 pairs of shoes. How many different outfits does Jose have to choose from? So I'm going to start off by showing you why the fundamental counting principle works. And then we'll just talk about the principle itself. So what happens here is he could choose from 2 pairs of pants. So he's either going to choose pants 1 or pants 2. If he chooses pants 1, he could choose shirt 1, shirt 2, shirt 3, shirt 4, shirt 5, or shirt 6. If he chooses pants 1, shirt 1, he could pick shoe 1, shoe 2, or shoe 3. If he picks pants 1, shirt 2, he could do 3 different shoes. Same thing here. So we'll have 3 on the end of each one of these. So he could have pants 1, shirt 1, shoe 1. Pants 1, shirt 1, shoe 2. Pants 1, shirt 1, shoe 3. So what you can see is he's going to have 3, 3, 3, 3, 3, and 3. So he's got 1, 2, 3, 4, 5, 6 threes. So he could have 18 ways just choosing the first pair of pants. He's going to have the same thing happening with pants style number 2. So with pants style number 2, he would have 18 choices. So total ways that this could happen is 36 ways. So how many different outfits does he have? 36 different outfits. Now some of you may realize that the number 2, the number 6, and the number 3, if you multiply those together, you get the same thing. 2 times 6 is 12, 12 times 3 is 36. So the fundamental counting principle says if you have this many things, this many times, you can multiply those numbers together to find out how many ways something will happen. Let's see what happens on the next problem. So it says he's designing a board game and trying to figure out all the possible outcomes. So when I see possible outcomes, I know that I've got the counting principle going on here. I'm going to multiply. How many different possible outcomes are there if he flips a coin and rolls a fair dice in the shape of a cube? So let's think about this. If he flips a coin, he has 2 ways to do that. If he rolls a dice that has 6 sides, there are 6 ways to do that. So there must be 12 outcomes, 12 different outcomes of flipping a coin and getting a fair die. And that makes sense because you could roll flip a heads on the coin or flip a tails on the coin. If you flip heads, you would get heads on 1, heads on 2, 3, 4, 5, and 6. Or you could get tails 1, tails 2, and so on. So you can see how there would be 12 total ways that could happen. Look at the next one. Landon's organizing textbooks. He has an English book, a biology book, a history book, and a health book. How many different ways, so I know I'm going to multiply, can he line the textbook on the shelf? So this would be a permutation. It doesn't matter what order I put these textbooks on the shelf. I want to line them up so that each one gets used. So I've got 4 books that I'm putting on the shelf. So I like to work the problem like this. I have 4 blanks. So when I pick a book and put it on the shelf, I have 4 different books here that I can choose from. I can either take English, I can take biology, I can take history, or I can take health. But once I put a book on the shelf, let's say I pick health, I only have 3 books to choose from to put in this spot. Let's say I picked English. Now I only have 2 books to choose from for this spot. And once I pick a book, I only have 1 to choose from for this spot. So how many ways can this happen? That I pick 4 books, then 3 books, then 2 books, then 1 book, is to multiply them together. So I have 12 times 2, which is 24, times 1. So there are 24 ways I can put the book on the shelf. Let's look at the next one. Ian is designing a new, I do want to go back to this one. You may at some point in time see something that looks like this, where you have 4 exclamation marks. This is a perfect example of that. When you take a number and have an exclamation mark, that means you take that number times itself. That number times each number underneath it. All right, let's look at the next one. Ian is designing a new board game and is trying to figure out all the possible outcomes. How many possible outcomes? So this means I'm going to multiply. Are there, if he spins a spinner with 5 sections, so he's got a spinner with 5 sections, and they're labeled Monday, Tuesday, Wednesday, Thursday, Friday, and he's doing a 6-sided dice. So there are 5 ways he could get this, and then 6 ways to get the dice, so there must be 30 total ways that this could happen. He could have Monday and a 1. He could have Tuesday and a 1, Wednesday and a 1, Thursday and a 1, or Friday and a 1. Or he could have Monday 1, Monday 2, Monday 3, all the way down. Monday 2, 2, 2, 2, and 2. So there's 5 ways here. I've messed this up. So I started Monday, Tuesday, Wednesday, Thursday, Friday with 1s. So then Monday, Tuesday, Wednesday, Thursday, Friday with 2s. And then Monday 3, Tuesday 3, and so on. So there will be 5 things that could happen with 6 dice, so that's how you get 30 ways. Here's the next scenario. 2 students, Aiden and Gavin, line up behind each other. How many ways, so this means I'm going to multiply, can you stand in line? So I have 2 friends standing in line. Whenever I pick the person to go in the front of the line, I have 2 people to choose from. But once I pick someone to go first, there's just 1 person left. So there are only 2 times 1 ways, so there are 2 ways this could happen. And this one makes sense, because Addison could go first and then Gavin, or it could be Gavin then Addison. There are only 2 ways that this can happen. Gianna's designing a new board game and is trying to figure out all the possible outcomes. What am I going to do? Multiply. How many possible outcomes are there if he flips a coin and rolls a fair die in the shape of a cube? So he's going to do 2 things. He's going to flip a coin first. And how many ways can you flip a coin? There are 2 ways. It can be heads or tail. Then for the next thing he's going to do is he's going to spin the spinner that's labeled either walk, run, or stop. So there are 3 ways. Whoops. Sorry, I read the wrong problem here. I was on the back side. Let me do this one again. Gavin's designing a new board game and is trying to figure out all the possible outcomes. How many possible outcomes are there if she rolls a fair die in the shape of a pyramid? So let's think about what that would look like. Here's a fair die in the shape of a pyramid. So you can see there are 4 sides. And has a spinner with equal sides, walk, run, stop. So you have walk, run, and stop. So there are 4 ways that the pyramid can happen, and 3 ways that the spinner could happen. So there'll be 12 possible ways that you could roll a pyramid dice and spin the spinner. How many possible ways are there to spin 4 spinners labeled red, blue, and yellow? So I've got 4 spinners I'm going to spin. On this first spinner, there are 3 things. I could get red, blue, or yellow. On the second spinner, I could get red, blue, or yellow. Same thing on the third, and same thing on the fourth. So this would be 3 times 3 times 3 times 3. Sometimes in the ACT, they'll just leave it like that. Or you could go ahead and multiply that out and see that there are 81 ways. A block has 3-number code made up of 28 numbers. If one of the numbers are allowed to repeat, this is important, how many different ways can you choose 3 different numbers for a unique code, distinct? It only happens this way. So I have a 3-number code, and in each one of these spots, I have 28 numbers to choose from. So I have 28 things that could happen here. It says that we can repeat the number, so that means I could put 28 numbers here or 28 numbers here. So I would just multiply that together. 28 times 28 times 28. So there are 21,952. Let's change this problem. What if it says that you're not allowed to repeat? So in that particular case, if I'm not allowed to repeat, there's 28 numbers I could put here, but once I choose a number for this spot, I can't repeat it. I would put 27 here. And once I choose something for this spot, I can't repeat it, so I would only have 26 to put in this spot. So in this particular case, there would be 19,656 ways. Justin is organizing textbook on his bookshelf. He has an English textbook, he has a math textbook, a history textbook, and a writing textbook. How many ways can he line the books up on the shelf? So he has 4 books that he's going to line up. He can put any of the books in the first spot. Once he picks a book, he only has 3 for this spot, 2 for this spot, and 1 for this spot. So there are only 24 ways that he could arrange these books. 12 athletes at a track meet. How many different ways can they finish first, second, and third? So I don't care about how all 12 people finish. I only want to know who gets first, second, and third. How many ways could this happen? So if you think about runners coming across the finish line, 12 people could be first place. But once somebody takes first place, there are only 11 to choose from here and 10 to choose from here. So how many ways could this happen? 12 times 11 times 10, 1,320 ways.